In this video, we'll talk about graphing linear equations that are in slope-intercept form. So let's talk about slope-intercept form. So its overall structure. You'll have y equals mx plus b, where m and b will be given values. So like, for example, y equals 4x plus 7. This would be written in slope-intercept form. Our y's and our x's are still variables. This m and the b, which in the case, for example, 4 and 7 respectively, have meaning. So if we look at b, this is our y-intercept. Sometimes also known as an initial value. So I know it goes through the point 0 and then b, whatever b is. So in the case of 4x plus 7, I know it goes through the point 0, 7. That gives me 1 point to work with. And then we look at m. M is the slope of my line, also known as the rate of change. And this would be my change in y over my change in x. So in this case, 4, which is technically 4 over 1, which would mean that I go to the right once, and then I go up 4 units. Then I can plot another point from 0, 7. And we'll do an example to kind of put this into practice, but it can be a really slick way of graphing equations. So let's do an example. Let's go ahead and we can make our coordinate grid. So the first thing I'm going to do is I'm going to look at my y-intercept. That's what I'm going to do first. And what this is telling me is that it goes to the point 0, negative 1, which means it goes through that point right there. And my next step, I'm going to look at this number. Whatever is multiplied times the x, that's my m. My slope, which means my slope is 2 over 1. Okay, which means that I go to the right 1 and up 2 units to my next point, and then I can keep doing that. Right 1 up 2, right 1 up 2, so on and so forth, until I make a line. We could also go left 1, down 1, and I should get the same sort of line going here. And we look at the slope, we look at the rate of change. It's constant with a line, so it makes, I guess, a linear function. And we can use that structure to our advantage here. So let's look at another example. Now again, I want to make my axis here, or my coordinate grid. Okay, now again, I'm going to look here first at my y-intercept, the b, which means I go up to 5, there's my y-intercept. And I'm going to look second at this negative 3, which means that I go to the right 1, down 3. So I know it goes to the point 1, 4 as well. At that point, I can continue with that trend. So I go right 1, down 3 again. I'm down to negative 2. And then I can connect the dots and make my line. We can use this as a quick way to graph linear equations, even if the slope is negative. It just means it's going to go down as it moves to the right. So let's look at another example here. In this case, we have a fractional slope, but that's okay. So let's make our grid. Now again, I'm going to look at my y-intercept first. So right there, we know it goes to the point 0, negative 2. Now, if I'm looking at 3/4, so 3/4 is equal to m, which we can say that's equal to our change in y divided by our change in x. It's the rate of change, meaning for every 4 units I go to the right, I go up 3 units. So instead of trying to figure out, okay, where 3/4 is, I'm going to go to the right 4 units and up 3 units and plot my point. And then I can make my line. So fractional slope is not a problem. It just means that instead of going over 1, we'd go over whatever the denominator is, to the right usually. And we can still use our structure to our advantage.